Hello, everyone. It is March 14th, Tuesday, March 14th, 2023, and I can hear myself on repeat on echo. Here, let's mute this. Okay, took care of that. Hope everyone's doing well tonight. I'm going to do a fun, early, quick stream where we talk a little bit about the Kaggle competition we were looking at recently. And let's try to implement a solution using Pytorch lightning. Do you know what Pytorch and lightning is, people? Hello, chat. Hey, Maker and Kurian, welcome to the chat. Hope you're doing well. Let's share my screen, shall I? All right, so here I have my terminal up. We are in this Kaggle ASL signs GitHub repo that I created a while ago on stream, and we were looking at a Kaggle competition called let's go to Kaggle, go to competitions, and this is it: isolated sign language recognition. So we're giving a bunch of data with people doing sign language, and we're trying to recognize what sign they are making given some data that's fed through MediaPipe. So I'm just doing a quick overview on everything, but then we'll dive into the modeling stuff. So MediaPipe is open source, and it allows you to detect faces, hand points, and also this pose estimation using the holistic model takes these three things: the hand, the pose, and the face detection, and gives you all these data points. So the Kaggle competition is they're giving us these data points. They're not giving us the video, but giving us these data points for a bunch of videos of people signing a handful of signs in American Sign Language. Our task is to be able to detect that given the videos. So there are a bunch of solutions out there already, but one of the main things about this competition is that there are some restrictions as to how the model has to be uploaded. Before I do that, let's look at the chat. So we got someone saying, "What's up, Chan?" Thanks, Nasser. And we have Ken. Hey, what's up, Ken? Thanks for hanging out with us in the chat room. All right, so I had looked at this before, and actually, let's load up VS Code here and show you some of what we have done before. So, the restrictions of this competition that make it somewhat unique, that's not typical of a Kaggle competition, are in the evaluation, maybe they tell us. Requirements, prizes, I think it might just be in the description. It needs to be, so there's a time requirement. They probably talk about it here. Yes, 40 megabytes of storage. So they're requiring the submissions to be in TensorFlow Lite format. If you don't know what TensorFlow Lite is, then Google it and tell me what it is, because I kind of know what it is. I kind of don't know what it is. Essentially, it is a version of TensorFlow that can run on edge devices like your cell phone. So it makes sense that they would want this model to be able to take video from people's camera and then predict what the sign is. The interesting thing is, though, you can train your model in Keras TensorFlow, or you could train your model actually in Pytorch and convert it to a TensorFlow Lite version. So the way we do that is using this TensorFlow Lite interpreter, and then we convert using this way. So I actually ran into some issues trying to do this with the Keras model that I had created. I haven't quite figured it out, but it was frustrating. This weekend I was looking at it and wasted a lot of time, but that's what we do when we're working on stuff like this. It takes time. So I can kind of show you what I had been working on, which involves, hey there, big brains. Thanks, Zero. Good morning from India. What's up, Panduranga? Welcome to the stream. So I have been working on this code base where I basically have a trainer script. I guess before that, I have a feature generation script, which takes these raw features and converts them into NumPy arrays that we cache then on my local hard drive. I try to make everything in this configurable with a config file. So basically, if I wanted to run this feature generation, I could provide it a specific feature generation config file that tells it some things like, you know, the number of dimensions that I want it to have, the number of frames that I want it to resize to. And if I go into here and I did Python source cache features and I do config file, then I could show it the config file and yeah, run it on one of these config files. Let me just create a new config file. So it'll actually make the NumPy data on my hard drive based on this name. So I'm going to make a feature 5 and then I have this flag, or I guess it's a carryover from someone else's code that has a flag to run a quick version of this. Yeah. So quick test is true. And that will actually run this in a fast version. You can see what it looks like. So the reason why you have to, in this competition, it's important to have all the pre-processing done in a very structured way. And of course, there's something wrong with my config file. I was messing with this cache features. I think that's what messed it up. But the reason why you have to really worry about how this pre-processing is done is because everything for this competition just has to be as if the model, this TensorFlow model, will take the input data as it's provided and it has to do all of the data manipulation in TensorFlow, which can be a little bit frustrating because there are things that pandas can do, like a forward fill, or NumPy can do, like easily averaging or finding angles or computing distances in 3D, which aren't necessarily implemented in TensorFlow, and it was causing, you know, some issues. But it is what it is. Another thing I had set up is this train script. So this train script basically takes these cached features let me go into this source trainer, takes these cached features and starts to run a training loop on it. Now the thing about the trainer is it also has a flag. So like this training config would let me turn on if I saved the results to weights and biases. And then I have a local version of weights and biases up that actually lets me see the results of each experiment that is run. So you can see that this experiment for fold 0 and this experiment for fold 0. So there's some differences in these two different runs. And you can see the validation accuracy is much higher for this gray run. That's because it's a bigger model. So speaking of bigger models, bigger is better most of the time, but there's also a requirement in this competition that not only does it need to be a TensorFlow Lite model, but it has to be less than 40 megabytes, which is a pretty, small to medium sized model. And it needs to run each example in less than 100 milliseconds. So you can't do crazy ensembling of models because then it'll take longer than that requirement. TensorFlow only. Yeah. So interesting. So that's part of their rules. Yeah. So Kaggle is owned by Google. Google is a TensorFlow has created TensorFlow and Keras and all that stuff. So they are definitely pushing to not force everyone, but to make everyone use a standard version of TensorFlow Lite for this inference code. Now, that being said, you can still train a model using Pytorch. You just need to convert it. And this is a really good notebook that I looked at earlier, and actually think I had run this locally, that I was thinking we could try to manipulate and run a Pytorch model with this. Wow, this is interesting. I've done many Kaggle competitions all in Pytorch. Yeah, so you could still, like I said, you could still use Pytorch to train your model. It's just inference that you need to convert it back for. So let's do this. I'm going to make a directory called so I'm going to make this American Sign Language Lightning folder, which we can then open up here. And we're gonna create some files in here. So let's touch a trainer.py, and we're gonna touch a model.py and touch. Actually, let's remove model.py and let's make a directory called models. And then let's touch. What else do we need? Let's make a directory called datasets. And yeah, okay. So now we have in here this trainer.py. And let's go ahead and start copying some of this stuff. So, yeah, this will get us started. I think we could definitely train using PyTorch Lightning very easily with what we have so far. Oh, look, this person uses NB Black as well. I have enough issues with implementing custom things in TensorFlow. I can only imagine TensorFlow Lite adds even more restrictions. It does. It does. It can be frustrating. Hey, Trebuvan SB, welcome to the chat. All right, so we have some imports. I'm not quite sure all of these are actually needed. So let's put these up at the top. And oh, that's another thing. We're going to make a directory called configs. Yeah, that's going to be our configs. And then we're going to add this. So what is this adding? It's adding this weights and biases. Actually, let me go to my GitHub. Not Twitch stream projects. Where is it? Where is it? Repositories. Am I logged in? Yes. ASL signs. Let's go to branches. So I have 3 branches. Messy work, TensorFlow training. Yes, I already did this a while. All right, so let's actually pull some of these over. So I created this test PL before, which basically just tests to make sure PyTorch works. So let's go into Lightning. Oh, we're already in it. So Python test PL and make sure this works. Is it stuck here? Oh, there's using all my GPU resources. So that looks okay. If I could stop the process, that'd be nice. All right, let's kill this. pkill Python. There you go. Now you're done. Let's remove that. All right. Exit out of there. This file is gonzo. Let's not reinvent the wheel. Let's see what this trainer v1 is that I created a while ago. So I appended it with data sets. Okay. So what does this do? What does this do exactly? From model CSN. Okay, so models. I'm going to put this in my models directory and make this called models, actually CSN 01001.py. This is our CSN, and we need ResNet 3D also. Hey, Sonetta Gaming. Thank you for the sub. Appreciate it. Just appeared. What's happening? We're doing Pytorch lightning. I've got to spin the wheel though. Oh, that's right. I was making this ResNet 3D model before I realized that it wasn't going to work because this model is huge. I was watching since the start just came from YouTube. Oh, thanks for subscribing. Okay, let's go over to Twitch, see what's going on here. Sonetta Game, first time chat. Nice. Thank you for subscribing with Prime. By the way, anyone who's watches on Twitch, if you're not watching on Twitch, you should. That's a good place to watch. YouTubers, come over to Twitch. And then on Twitch, you can subscribe with Amazon Prime. It is completely free with your Prime membership. And that will come straight out of Jeff Bezos' pocket. And it'll fund me getting things like GeForce RTX 4080s, like the one back there. And I'm giving that away. I'm giving this away. I'm giving this away 2 GPUs. Number 1. Number 2. Those are going to be given away to a random viewer who joins a Kaggle competition, which we're launching, and one to someone who wins that competition. So make sure you're following me on all the social stuff. You're subscribed on YouTube. You follow me on Twitter. And you join our Discord. Join our Discord. That's a super cool thing to do. By the way, someone was impersonating me on Discord the other week. And it was causing me to, or I had to ban that person from trying to scam people into thinking I was trying to get them into a investment into crypto or something. If you get a message from someone on Discord looks like me and says they want you to invest in crypto, they're a scammer. My ISP offers Amazon Prime, Disney. Ooh, you get all the good stuff, MMD. All right, so this landed on Do Nothing, but I do want to thank you very much, Sonata Gaming, for the Prime subscription. All right, so now I'm remembering what I did here. This was, but these models don't work. So we're gonna figure out at least how to get this training, and we're gonna train it with a config. So this is gonna be importing from a directory deeper that's called models. Resist appending that path. And then we have a datasets directory here. Yeah, so we basically append the sys path so that we can import from these. And I'm actually going to change how I do this so that I can add this as a config. Some of the imports you'll notice that we're using Pytorch lightning here, Pytorch, torch metrics. We have weights and biases, although I don't think this is being used. Same thing with this. So I think we're good on that. Okay, so in data sets, we need to go back here to this. If I knew how to like move stuff from other branches, that would be cool, but I don't. So we are where we are. Data sets, new file. What did I call this? CV2 2D. Oh yeah, this is when I was trying to make 2D images. All this idea, I should have read the description of the competition before, so I knew that that none of this was going to work because it's too large of models. Maybe the idea can still work if I'm lucky somehow, but not anytime soon. Okay, so this import should work. I guess that the linter does not know that it works, but that import should work. And then these are all the configs we are feeding it. All right, so what do we have here in our config? Let's make a config file. Let's make our brand new config Python file. And I'm going to copy the idea of what I have with my base configs. Oh yeah, this is going to be a YAML file. Why YAML? I'll show you. Then I need to take everything out of my trainer. That is a config. And we're going to add it like this. We need these to be colons. What does this allow us to do? This allows us to input directory. Yeah, I'm going to copy a lot of this stuff over. So in my other config, I have these paths. Like this. Huh. Well, this stuff's indented 4 spaces, so let's go ahead and do that. And then in my trainer, I can import this config file. So let's see how I did this in my other trainer. Getting confused here with all my different versions of things. So I have this arg parser that basically takes in a config file argument. It then will look in the config directory for the config file. So let's make this conf 001, path to the config file. And then I have this git config. No, I know what I did. Omega config. Yeah, so then I make this the config. So I have my train CSV path, feature out directory, landmark files directory. And that's going to be this base directory plus my train landmark files. There we go. But before I do this, actually, let's just see if I can run this. Let's just see if this works. Python trainer.py. All right, what is people talking about? Hello, sir. I'm a new subscriber. Welcome, Mandar Moore. Thank you for being a subscriber. It wasn't me, even though I wear glasses. So making a model for the competition, or is it ML meta mission? No, I'm making a model for the competition. I'm on Kaggle, but I haven't gotten around to doing any comps. Competitions are really fun. You should check it out. Hey, Rob, thank you for all your videos and efforts. Hey, Mega, thank you for hanging out with us tonight. Use sklearn previously and been keen to learn about others. Yeah, you got to step up your game a good bit to go from the sklearn world to Pytorch or TensorFlow, but it's well worth it. It's fun. My master, Sunya, what are we doing tonight? We're working more on this Kaggle competition for sign language detection, and we're trying to implement a solution in Pytorch. So I'm going to send you in the chat a link to Chris's. I've upvoted this, right? I've already upvoted this notebook. So this notebook that I linked to you is kind of the basis that we're starting on. And then I have a different model that I would like to use. So what happened here when I tried my trainer? From Onyx, import defs. Cannot import name builder. Let me see here. Oh, we also need to import argparse. Let's see, because there's a bunch of issues here. Import argparse. So let's try this. If I was to just go into IPython and try to import this. Cannot import name builder from Google Protobuf internal. Oh. Use an older client like 13.5. Solution is mentioned here. Install the latest version. Okay. All right. It uninstalled 3.19 and installed 4.22. This call from PB to Pi, you generate code is out of date. It must be regenerated with Protalk. Come on, man. Onyx, what are you doing, Onyx? Let's actually, am I using this prepare? I am not using this Onyx backend prepare because that is to convert the trained model to no module name model CSN. Yeah, that's right. So this is CSN 001. Oh, I need to do this maybe. And this is CSN 001. This is just importing our models. Okay, I'm here now. Okay, Trebuvulan, welcome. Can you use dark theme on your browser, please? It depends. Depends what I'm looking at. This is not cool. Lazy loader is not like this. Conda EMV list. Let's make sure I was running it from the right Conda environment. Pi 3.8, point E, neural chessboard, media pipe. Maybe I was in this Kaggle 2023 when I ran it before. So let's try this Python. Do you typically make a new environment for every project? Yeah, most of the time. I mean, I have this like base one called Kaggle. Now I've updated Kaggle 2023 and it's what I use just if I'm doing random stuff. Let's see how this fails spectacularly. Why is this in weights? Site packages, weights and biases is freaking out. Oh, wait, that's just because weights and biases is loading up TensorFlow, TensorBoard, and all that. This is the life. This is the life. Okay, dark mode on for you. Oh, then I have to turn on for everything. Downgraded pro buff. All right, so I upgraded pro buff too much. Maybe that's why it was... Maybe that's why it was messing up before. What are you guys saying? Sorry if I answer, but did you say they're starting a new Kaggle competition? If so, can anyone join? Yes, anyone can join the Kaggle competition. I need to decide like all the details, which I haven't done yet. But you can win a free GPU. You can win on just by joining and doing nothing other than joining. Or you could compete really hard and you can win by just making an awesome submission. Why should we use a custom environment instead of the default Conda one? The reason why you would want to create different environments, actually, we just ran into an issue that would be maybe why. So let's say your project, you want to use a certain version of Pandas, like you really want to use Pandas 2.0. I know it's not out yet, but let's say you do. Then you start to... you install it, it upgrades your NumPy, it upgrades scikit-learn or PyArrow or something else in the back end. It might cause your other programs to break when you try to run those. So everything kind of needs its own environment because there's Python packages in general just have so many dependencies that if you get things out of sync, you could really mess everything up. Now, if you want to take it to another level, Then you start to use Docker containers. And that's basically like taking your whole machine and making it into this one environment, this virtual machine that runs the program. But for everyday data science stuff, Conda environments work pretty well for that, or just Python's virtual environments. Okay, so what were we doing there? We were training the model on this data set that I had created. We're using this data set that converted these NumPy features to a tensor, and these were ones that I had created before. But we are not going to use that data set. What we are going to do is we're going to have our trainer allow us to configure the data set and the model that we want to use. So how are we going to do that? Well, I'll show you right here. First thing we're going to do, which isn't that exciting, but I think it's pretty cool, is actually get this all to be accessed using our arg parser. So I thought I had put this in here. I did get args. So the way I do it here is in my if name main name, I'm going to do this. And then I'm going to also make a get config like this, get config. I think in my cache features, I have a get config. No, I don't. But let's go ahead and do it this way. So instead of running run, we are going to get our config file, which we will provide it a config file path. Then we're going to do from omega config, we're going to import omega config, which will just be a cleaner way of loading that YAML file as a config dictionary. And then we're going to add the name of that file that we're using, that's our config, and we're going to add that to the config itself. So now let's go ahead and get config. And basically everything in uppercase here, we are going to abstract out to the config. I don't know why this import is there, but let's move it up. So they're kind of doing a config here differently. So let's add this to our config file. So we have our paths, then we have this config YAML is being a little strange. All right, so we all have model name, and this will be the model. This will be the model that we're going to pull in from. We're not going to add this pool type. Yeah, we'll do this later. And then we're going to do a config dataset file name. And we're going to pull a lot of this stuff in. So train, we don't need to give it this numpy config. Fast dev run, we will set to true to test this. Oh, wait, this is going to be config fast dev run. Maybe I need to back up and show everyone what our what Pytorch lightning actually lets us do. So Pytorch lightning is kind of a wrapper around Pytorch to take away a lot of this boilerplate that you commonly make when you're writing Pytorch code. So typically when you're using when you're creating a Pytorch model, you create all of this boilerplate code like a classifier model name. You always have a training step where you're iterating over the model. You're doing back propagation. You're computing the losses. You're updating the optimizer. You're updating the learning rate scheduler. It's just like this stuff that you do over and over in each time you write the code. Pytorch lightning tries to abstract that out away from you a little bit so that you can do it. You can kind of use their infrastructure, and then they can do things like let you scale to using multiple GPUs, or actually just have your code kind of in a cleaner way that anyone else using Pytorch lightning would understand. So yeah, normally you'd have to create your data loader with your sampler, basically telling your data loader how to pull that data out and feed it into the model. But this is what your lightning module ends up looking like. You can set all these configs. So we could pass a config here when we initialize it. And then when we do like our training step and all that, we just keep that into these set names that meet the convention of this this stuff. So there's also, I think, like a get data loaders, all this stuff. But all that's to say, we're not going to go into too much detail about it because we already have most of this code written for us because someone's made this for us. All right, so we pass it this model config. We'll pull in this config. I don't know why we pulled this in. And then let's just pass this in. Let's see how it does with this. I know this is going to fail, but let's see how it fails. Time is not, well, that's one way of failing. We just need to import time. I don't need that simple namespace anymore. Assign to index. So this sign to index is essentially just get sign to index. Let's see if this is correct. It does look right. It kind of copied my Copilot copied my initial code. Sign to index path. All right, so then we're gonna do config sign to index equals get sign to index in this config path. Yeah, I think we should be good here. We're gonna delete all this stuff once we're sure it's running without it. By the way, maybe I should make this a little bit bigger. Is bigger better? Is that better? What are your views on George Floyd? Oh, man. I don't. Yeah. Let's Copilot. Yes. Maybe try Co. Do you think GPT-4 will be able to solve all these issues for us? Hello, I'm studying data analytics from Coursera, so it's difficult to understand this, but I will do this in the future. Yeah, you will. Well, so why isn't everybody who codes in Pytorch using Pytorch Lightning? I mean, that's the thing about Python and open source code. You could choose to do anything the way you want to. People have their legacy code that they're familiar with and they like using it. Pytorch Lightning is also one option. There are other packages that do the same thing of wrapping this boilerplate. So really, it's the sort of thing where they put it out there and they make good documentation, and then people can use it if they choose to. Some people just want to have all the abilities to tinker with stuff in their models and not have to worry about what is the Pytorch Lightning code doing in the background. Because sometimes when these packages try to make it simpler for you, they actually just handcuff you into having to use their way of doing things. And it's not always the best. So yeah, there's no one size fits all solution. Yeah, let's just add this to make it have a timer. Hopefully that answers your question. Sometimes that's for the best, not reinventing the wheel. Yeah, but it's like, what wheel do you want to use? Whose wheel? No such file or directory. There should be that file or directory. Conf. Why is it saying this directory doesn't exist? Is it because I called it config instead of configs with an S? So I need to call this let's call this with configs. And let's also yeah. This needs to be like this. Let's go here, Python trainer. I'm in the wrong config trainer. I edited the wrong one. Let's not save that. Let's save this one. This should be in configs. There we go. Or I could have called it with this trainer config file as configs conf 001. Boom, womb. That's right. Config file. So this should be a path. So let's run this as an actual pathlib path. All right, so sign to index path it's saying is not here. All right, so this is actually the label JSON. This is basically the file that converts from the numbers to the actual sign that we're trying to predict. Like if it's yeah, I don't know sign, but number 0 would be like smile or something. Fest should be fast dev run. Thus why some may not want to use Pytorch Lightning while others might find it helpful. Yeah. NumPy dir. So this data module, this loads our data loaders. So this pulls in our CSV. It decides which fold to run on. It doesn't actually use any of these. Does it actually use this NumPy directory? Oh, it does because, oh, that's right. So Pytorch Lightning has this cool thing where you do this self.save hyperparameters, and then it'll add this self.h params that you can then pull all this stuff from. So it needs this NumPy directory, right? All right, so where do? We go into this training loop. We give it the model config, which should have all this stuff in it. So like the NumPy directory, the seed should all come from our config. Let's just call it our global config, not the model config. Config will seed everything with just the seed from our config file. We'll use this as a config. We'll also use this NumPy directory. Everything we want to be in our config file. That way when we change something when we're running our training, that we only have to edit this config file and not the actual trainer. So this NumPy dir. Why don't I have the NumPy directory? Let's look back in GitHub. Sorry about the bright lights. Let's look at our trainer NumPy directory. I had it saved as this. So I'm going to just call this NumPy dir. Here in our config, we'll use this for the time being just to test out our training before we change the model type. This will be our config file. There we go. I think that we're set up to run a config off of a config file. Why? What do you guys think about this? What do you guys think about config files? This is also called config. And then let's see where in features is used. In features. Yeah, we're not gonna. Did I change the in features? Don't think I actually used that. Yeah, let's try this again. I used to hate them, but I like the structure now of having a config file. Yeah, it's definitely helpful. I've worked with people that have convinced me of the power of config files. All right, so model name. Sorry, I'm jumping all around here. So it's failing because of I don't have this model name in my config. Really, all of these should be in our config. Where's this config.model name being an issue? Missing key model name. See, that's the nice thing about using this. But I'm a little thrown off as to where it doesn't have this. Or why it's even looking for model name. Fast dev run. Okay, so that's actually in this model. That's actually in this model that we're giving it. So let's do this. Model name. That's where I did a 50 IR. Definitely going to change this later. Why is it complaining about this? Come on. Model name's right here. Model name. This. Let's also print config as this so we can see it when we run our script. I think I'm at the point where I'm good with deleting this stuff off. So I'm going to print this config file here. That's the weird thing is, look, yeah, so I've actually saved in the config file the conversion of sign to index. So these are the numbers and the signs that we're trying to predict. Like TV is 0, after is 1, airplane is 2, all is 3. So they're alphabetical order clearly. All right, let's actually see in this. Oh, that's why. I see why. I see why it's not working. It's because in these models, in our lightning model, this assumes that when we give it the config file, self.config, that it has lowercase model name, and it should actually be this now. Right? It's just this one model that's weird about it. Hey man, almost 100 people watching you on YouTube and Twitch. Awesome, keep growing. Thank you. B. Norman. Pool type. These are all things I just kind of have to do to get it working with the old version. Let's see if this works. Oh, that's right. I have the old version of the config in here. Hey, sign to index is not defined. Where is this? This is where we need to make sure that we don't have global variables. This sign to index has no place being like this. So model config, it should be self h params model config. Seems like too much. Shouldn't I just do... I can make this a little cleaner by doing self.config equals model config. And then length of classes is in our config. What was it failing for? Sign to index. You know what I can just do? Make it a lot clearer instead of doing all this inheritance. Num classes is 250. We just know that to be true. That's never really going to change, but still can be part of our config. And then we do, then it'll just be num classes and with no length around it. Hey, yo. Thoughts on GPT-4? When did GPT-4 come out? Did GPT-4 come out? Am I missing this? All right, so this ran all the way through with the test debug version of Pytorch Lightning, and it would train a model if we wanted to do that. Now, here's the thing, is I want to change this to use a different model. It's the biggest talk of the day. Oh no. Oh no, OpenAI, what did you do? Announcing GPT-4, a large multimodal model with our best ever results. All right, let's get some reaction.
For example, you can ask it, GPT-4 is the latest AI system from OpenAI, the lab that created DALL-E.
Okay.
GPT-4 is a breakthrough in problem-solving capabilities. For example, you can ask it how you would clean the inside of a tank filled with piranhas.
Oh,
and it'll give you some
yeah, I'm definitely going to ask about that.
It can also read, analyze, or generate up to 25,000
Write a
words
gothic
of
romance?
text. It can write code in all major programming languages. And it understands images as input and can reason with them in sophisticated ways.
What? So images can be input?
After we created GPT-4, we spent months making it safer and more aligned with how you want to use it.
More aligned,
Methods we've
okay.
developed to continuously improve GPT-4.
What do you guys think about
Help us
this?
as we work towards AI
GPT-4
systems
paper
that
is actually
empower us all.
awful. Reading is more like an advertisement about how
GPT-4 is the
good
latest AI system from
it
OpenAI,
is rather than
the lab
proper
that created
research
DALL-E.
paper.
And
Love your
ChatGPT.
tutorials and videos. Thanks,
GPT-4 is a
XPX.
breakthrough in problem-solving capabilities.
All right, so let's see what this live demo. Multimodal is very interesting. The training data used for models like this becomes a lot more general. Getting closer to one model rules them all. Well, Sendex is... Oh, he changed his name to actually being his full name. But yeah, that's... he knows what he's talking about. Let's talk about this. Let's see what it...
So the first thing I want to show you, let's see what it does.
Yeah, this looks like an Apple demo, right?
It kind of didn't even try, just gave up on the task. This is pretty typical for 3.5 trying to do this particular kind of task. If it's, you know, sort of a very kind of stilted article or something like that, maybe it can succeed, but for the most part, 3.5 just gives up. What we were just doing, evals. We have a
So I guess this is just going to be like a lot of testing by people. What is it writing code for here? Let's see what code it's writing.
And now the model can actually leverage that documentation that it did not have memorized, that it does not know. Is that see that the Discord, oh, it looks like we have a response. Perfect. So it's a screen, what kinds of applications it unlocks. But if you see, it says, oh yeah, message content intent was not enabled. And so you could either ask the model to write some code for you, or
what?
You could actually just...
What's he doing in a Jupyter notebook?
The old-fashioned way. Either way is fine. I think that this is an augmenting tool, makes you much more productive, but it's still...
He doesn't know the keyboard shortcuts?
And are the manager and knows what's
a Discord bot? He made a Discord bot?
And Boris...
Another Discord bot? Do we need more Discord bots?
Like a human.
Okay, I mean, I think we're going to need to see it. It's not, so it's not like a chat bot, or is it still it's still kind of as, kind of like the next version of ChatGPT. Is that right? Is that what we're looking at right there? I'm still trying to understand exactly what GPT-4 is. Ah, music's probably so loud for you guys. Sorry. All right, let's close that. That's interesting. Maybe I'll have a take on that later on. A Discord bot is what they show. Okay. All right, so we're going to make a new model file called... actually, let's just copy from this other one that I have. Our good old buddy Heng on this competition has been sharing a lot of interesting stuff. So this is the model that he's shared. It's a transformer-based model, similar to that of ChatGPT. Sorry, but he has this stuff coming from his config file. So we're going to add this to our config. Model config. Max length, num point, embedding dimensions, number of heads, and number of blocks. Probably want to make that uppercase in a little bit, but we'll let this be what it is for now. We're going to comment this out and see where max length comes in. That's in our transformer block, and this is where the net is actually created. So in the main network, we want to also get in a config, our config. Then we'll do self.config equals this config. And then we can do max length. Embedding dimensions. Number of points. What time is it? I got to go to bed at a reasonable time tonight because I'm driving in the morning. Num block, embedding dimensions again. So this is our transformer based model. Run net check. Run check net. So here we'll do config num point we'll just make a base config here. Num head and num block. This will let us take in this transformer model. Now let's see what else, where it's still failing here. Yeah, so we should just, as in our main, pass it in this transformer 001 in our main. Let's just add all these to the config. Config is going to equal all this stuff as a dictionary. And those need to be strings. Actually, nope. I had it right before. These all need to be strings. So let's do this. How do I do this in VS Code? That's the real question. How do I do multi-line editing? There we go. Is this wrong? Commas. Of course. There we go. So now that's our config file. And then we'll run net check with the config as an input. Add a trailing comma here. Hi, says JSites. Do you recommend Omega config for config management? I just used it in this one because I copied it from someone else's, but I've been appreciative of Omega config in this project for sure. So seems like a good package. I would endorse it. Just need to use it a little bit more. Not sure what's going on here. Oh, my indentation's off. Is that it? Something's being weird. Where are my issues in this? Max length. So pack sequent needs our config in it. Self.config. Or I could do it this way. Pack sequence gets self.config.max length like this. This is complaining because I have I need to have the non-assigned variable first. Then when I create my network, my net, it needs to take a config file first. And this num classes should not be there. That's in our config. Right? This doesn't seem too fun, but trust me, it'll make our life a lot easier in the end. So now I'm going to try to run it. Is anyone still alive out there? Maybe I should print this config before I add that one block. Oh, look, it worked. Wait, hold on. Yeah, so actually, let me go into models. I don't think I switched the model there. So let's run this transformer and see if this actually checks. Embed dimension must be divisible by num heads. $512 is divided by 4, right? So I must have screwed something up in here. Multi-headed attention. Embed dimension num head batch first. See where we define this. Embed in dimension num head out dimension. Yeah, I did that all wrong. I made this transformer block all wrong. I screwed it up so bad that it's not even a joke. Let's go to my original one just to make sure. Yeah, so this is embedded dimension, number ahead, embedding dimension. So that's wrong there too. Oh, I see what it is. It needs to be number of heads. There we go. This content is very relatable. Can you do some videos on Python Dash? I've been getting asked a lot about that. We need to do that. We need to do that for sure. Oh, hello. I'm awe of your expertise. Yeah, I don't feel like I'm showing that very well right here. Num classes. All right. So this number of classes needs to be in our test. Config. Look, Copilot knew it was 250 before we even wrote it. This is why I use TensorFlow. Okay, so our model is working. That was a comment, by the way. Camus said he uses TensorFlow. So this looks like it's working. This transformer model is working. What we need to do now is to make our trainer we want our trainer script to be able to take in the model file as a parameter. So right now we're just importing this NM model like this as our model. But what we want to do is actually use something called import. This is the funniest import you'll ever see. Import lib. It's an import of something that helps you import. And let me show you why this is really cool. So import lib will allow us to define a function like, let's just go to our other trainer. Let's call this PL trainer so we don't get confused. So PL trainer for Pytorch lightning versus our trainer for my TensorFlow model, not Pytorch, is here. And I have my get model, get data loader. Yeah, here. So I had a get model function here, but we're going to do it a little bit simpler here. With import lib, we're going to say get net. This will get our network, and we'll feed it the config file. And then we'll load in this model file as our network. Yeah, like this. And we'll return the network. So now with our config, our model file in our config, I like doing it that way. Now in our config, we have a model file name, and it's going to be transformer 001. And that will jump into this file and pull out the net object, which is our main network that we want to create. Get net. So now when we create this NM model as our init model. We don't want to do this anymore. We want to get model file name. Let's think about how we'll do this. So yeah, this should be our net. And we'll return this. This should work. And then, yeah, we want to provide the net. Before we were doing it like this, and we also gave it the config. So we'll give it the config equals self.config. There we go. Now let's go to Python train. Oh, Python PL trainer. And see what it's going to fail on. That's right. I called it model file, but in my config, I called it model file name. I guess saying model file name is redundant, so I'm going to say model file. Yeah, and then that should be good. Let's, while we're in here, also change this to dataset file. And then similarly, how we created a get net, we're going to say get dataset. And this will pull in our dataset class from our datasets. So what we need to do now is go into our datasets and call this normalize 001 as our first normalization. And then we're going to pull this out of hangs. Where are we? Hang. Transformer model. Dataset. We're going to pull this out and copy this in here. This will be our dataset class. We're going to have to change some other stuff into configs. That's okay. That's okay. We're also going to have to copy in this augmentation file, which will let us do some augmentation. This randomify. And this will go also in our datasets directory. You know what? I think the augmentation should stay in the dataset. So let's just delete this file, this augmentation one. We should do this. All right, so we need this preprocess to get a config file where we will take the config max length. We also need to make sure preprocess takes in this config, which needs to be passed through. This should probably be self.config. And our signed dataset is going to take in a config first, which we will set as a Class variable. Hi, fellow Python developer. How are you coding? Good. How are you? K-folds cross validation. What a great name there. What typing module uses uncommon in model implementation? Why typing module usage is... What do you mean? Ask that in a different way. POSIX. So this root directory, I know I have in my config already as my base dir. And this will be self.base dir. Yeah, so basically now when we called sign dataset, we need to make sure we give it the config file. What is this data frame we provide it? Yeah, I think that's good. Where is this giving us errors? Config dot, okay. This is a function I don't think we need anymore. This is also a function we don't need anymore because we're going to read that CSV in with our folds. So I'm commenting this out just to make sure it works, and then we will delete it. Read Kaggle CSV part. So let's do our data set here. We're going to create a signed data set with a config file again. This is in our check run data set. Our config is going to be passed into check run data set. We are going to read CSV from config.train CSV. And then pass this through to test. I think this should be good. And then this takes in a config file now, right? What else am I missing? Tell me, people, what am I missing? No, nothing's really popping out as an issue. I just needed to find my config. All right, so what is used in this? Our base directory. Look at this. Anish.documents ASL alphabet. That's like something that Colab has looked up and put in there. What did you learn during my data science masters? Everything I know. So let's give this a base directory. We also need max length. I think we're also going to have to provide train CSV. Here I call it train CSV path. I guess I call it train CSV path here also. Kind of don't like that I use that long of a name. So that's train CSV path. And the file name is this. Max length is going to be, what is it, 250? No, it's 60. Really, though? There we go. Now this should work, right? Probably not, but let's see how it fails. Let's go into data sets And let's run this normalize 001. LL, you said long? I did. Oh, the file name is long. It is long. Train CSV path. You guys are so childish. So childish. So GPT-4 was just defeated GPT-3 on my mathematical statistics problem, but it's getting hammered and it's limited to 100 prompts every 4 hours, pro only. So do we have access to GPT-4 right now? You're telling me I can run this right now? This is just the paper, right? Is there a link to how I can actually run GPT-4 right now? Microsoft confirmed that Bing Chat is using GPT-4. So the Microsoft one is the one that, like, the Microsoft model is the one that said it wanted to take over the world, right? That journalist was given access to it and it like went crazy. Brennan from Brazil, welcome to the chat. Otherwise, you can use it via ChatGPT Plus. So are you saying that I can go into chat.gpt and I can just run GPT-4? Are you GPT-4? What I've found with coding with ChatGPT recently is what ends up happening if the question's at all hard, it'll give you the wrong answer. And then I end up spending more time trying to be like, no, you got to fix this. You got to fix that. And then I could have just done it myself. Okay, so I don't know what that's all about. Where are we? We're using Pytorch Lightning, folks. Got to go back here and make sure this works. Dict has no attribute participant ID. Okay, I see what's going on. Run check dataset gives the config. We read this data frame and then sign dataset takes config first and then dataset. I have these two things swapped. Ha! How long would it take ChatGPT to figure that out? It probably wouldn't have made that mistake in the first place. All right, here we go. It's working. The dataset loader is working. That's great. That's a great sign, folks. That is a great sign. Now what we need to do in our Pytorch Lightning trainer is change this dataset. Change this dataset to return. No, so what we need is get dataset from the self config. And this will take dataset file and it'll pull pull in the signed data set from there. So when we run this get data set, we're going to pull in the signed data set and we'll return this. Pull the data set class from the config file. from the file reference in the config. So then we'll get a signed data set. And what are we going to do with our signed data set? What are we going to do, folks? We also need to make sure this is normalized 001. So all of our firsts. Signed data set, we're gonna give it self.config and the data frame. Right? And we're going to return this. I think this should work. What is the data frame that we feed it, though? Yeah, so it's going to get the train data frame, which is looking at just the fold that we want. Yes, this is perfect. This is perfect. This is perfection. Okay, it's far from perfection, but it's pretty fun for me. Let's run our PL trainer. We're using hang. Hangs. Where's hang? Let's look at this competition and just show you a little bit of what we're using. This is Heng. He has a Pytorch transformer model that he designed for this problem specifically. The code is probably not going to run for me this first time, but we're going to try. If we get something to run, I'll be happy. And then I'll clean it up later. But he has also been pretty active commenting on this. Oh, let's look at the leaderboard. So his solution has gotten him into 7th place currently. He's just saying he's still using this 4-fold transformer. So if we get this trained on 4 different folds, and we're able to ensemble those TensorFlow light models, we should be able to catch up to him just because he's so nice in sharing his stuff. Now, the thing about Heng's way of contributing to Kaggle, I appreciate it. He's very big on sharing and will share everything he's learned, and he's very smart and very sharp and always trying out great new things. But he'll just start a thread where he'll kind of do a data dump of his thoughts, and then he'll also provide some of his code, but it's usually pretty hard to implement because there's a lot of import stars from other packages that he doesn't necessarily have included. So it can be sort of like a rabbit hole of trying to figure out what's going on, but we're going down that rabbit hole tonight. And he isn't using Pytorch Lightning. So we've kind of taken his model, his data set, and we're throwing it into this Pytorch Lightning architecture to see if it'll work. Or did they ask Darm? He is a savant. Yeah, he's definitely... He did not use ChatGPT for this because he's been doing this for many years before you were even alive. Okay, maybe not that long ago, but... Okay, we're already getting a bug. PL trainer. Is it because I just like put a typo in my config? Yeah, it is. I put this backslash there for that little thing. Okay, ASL data module object has no... Okay, so we have this ASL data module. Remind me what ASL data module is. That's a Pytorch Lightning data module that wraps our data set. That's where we're setting up this signed data set. So it's saying this ASL dataset module has no config. I guess we forgot to provide it the config. We need self.config equals config in this. And then when we create this, we need to provide it a config, which is, yeah, our config. Right? And we think everything should run through. Gotta configure. What are you talking about, Camus? All right, so it broke. I saw this error before, though. What is going on here? Batch must contain tensors, numpy arrays, and numbers dicts found. Pandas core series. I think it's because of the collate function. Yeah, this null collate is what we need to provide it. Let's see if this is in Pytorch lightning. Return either padded tensor in a dataset or a list of variable length tensors in the data loader's collate function. So where do we put this collate function? Use this for data loader, data module. Let's see how it's defined here in our thing. It's when we create our data loader, we provide it this null collate function. Let's see if I can do it here. So we need to import null collate from this. This is creating our labels. So we need to, let's see if this will work. So when we say get dataset, we also need to return null collate, and that's going to be import lib. Yeah, that was right. Get dataset. Yeah, we have to separate that out, I think. We'll provide this to config file. And we're going to have to create this get null collate function. Return that and not return it here. Not quite sure if this is going to work. Stack Overflow. Dave, I have a custom Pytorch dataset that returns a dictionary containing class object queries. All right. Let's. So. This can't go right here. That's right, because that is when we create just the base data set. And then here, when we're actually doing it here, when he's showing how we do it here, it's when you have your data loader. This is where we need it. This is where we need it. Probably should only import it once. Yeah, we should probably only import that once and make this reference to self. And we do this when we init. Let's see how this works. Data loader got an unexpected keyword argument. You gotta be kidding me. Data loaders can take. So we need to look at how Pytorch lightning. See, this is exactly what I'm talking about where you want to do something and you're kind of handcuffed by the way they do it. So you kind of have to learn how they implemented. All right, so I know this is light, so I'm going to darken it for you guys. And then let's look here. This is in the Pytorch lightning source code. Train data loader. Self collate. Oh. Oh, so if we... What class is this? Transformer data module. Oh, this is lightning transformers. This is not Pytorch lightning. Let's try, just because I think this might work. When we create this data module, we might be able to do it this way. You need to wrap the data with transforms.compose before you return it. I'm pretty sure though when I do, okay. Oh, this is where yes, yeah. Yeah, there we go. I think this is going to make it work. Please, please work. Too many values to unpack. Okay, so this is good. X, Y equals batch. So now we're into the part where we're messing with the forward pass. All right, it's just getting interesting and it's almost 11 o'clock. So I'm going to have to end here soon. But this is where we're going to take this forward pass here. And look at how hang let's see how he did it. So I think in Pytorch Lightning Trainer on the forward pass, you have a batch coming in of data. Maybe that's not how this data set works. This is just putting it all on CUDA. He's doing auto casting. Let's look at the train loader. When he enumerates over the training loader, he gets T and then the batch. All right, so when is he passing that to the network? Net. It just takes the whole batch. Yeah, that's because our data set data set when we run get item just returns a single dictionary. It's not like it is in the other version of this data loader. So we were going to, instead of returning doing this in our forward pass, I believe we just need self.batch because that's how he's feeding it in. I'm sure there's more that we need to. Okay, so this is also returning X, Y, and prediction. And prediction out is out one. In the forward pass of this model, it returns just an output. Output has the sign, which is the softmax of the logit of the output, but there's also, yeah, it provides a loss. So he's providing as a dictionary. ChatGPT-4 is only for Plus users, right? Giga Chad Hang. Yeah, I know. We're learning something. So we kind of have to, this kind of goes against our whole paradigm of what we're doing here. This is returning our output. Just gonna batch dot output equals self dot forward pass of the batch. Now we need to know how does he compute? He's computing the loss within the model. The label loss is here in the output label loss. And then also in our data set, we need to look at what the output is. And then this stuff's being logged. This is also not going to be like this. It's going to be this is going to be self.forward pass is going to return our batch and our result. We already ran the sigma on this. And that's going to be the, let's pull this bad boy over here maybe. That's going to be our sign. If loss in output type. Okay, so this all depends on the output type. And inference and loss are both in it. Okay, so input type is going to be that makes this shared step a lot easier because we can do the forward pass, which is the batch and result, and here it's going to be our sign. And where's the labels going to come from? That's going to be from the batch sign. I'm not sure if it's quite that easy. And then we need to do the same thing here. Shared step is going to be our prediction. Hello, Penta Panda Top. What's up? How's it going? We're just deep in this, trying to reconfigure this to take out the output of this. And also we should pull this over here, normalize. It's definitely hard with this screen. We need this like this. All right, so this is the label. That's going to be our... So basically y equals batch dot label, and y pred is equal to output dot sign. Should call this result. And this batch dot label here. Let's see if this works. I can't focus on coding. ML basics are killing my brain. You'll get there. It's all because you're interested in the topic, right? I believe in you. Y is referenced before it's assigned. That's because I did not finish this. In our forward pass, what does view -1 in Pytorch mean? Let's ask that question and get an answer. What is view -1? Oh, that's a cute puppy. That reminds me of my old puppy. View operand flattens a tensor if it was already flattened seen here. Okay, so yeah, that's about right. -1 is this is reshaping it into that. So, but this might not be a tensor. So this should be batch label view1. Label here is just the d dot label, which is yeah. How does he do this in his training? I guess he's not calculating loss. You know what? I think all this doesn't even need to be done because we're not even handling it that way. I just needed to comment that line of code. What up, Kish, Milita? How's it going? Going well. Self.scale is none. Attempted, but underscore scale is none. I'm going to have to probably end here soon. It's been a fun stream. If you've had fun, put F in the chat. Let's print F 100 times. There we go. Fun. Did you guys have fun? I know this is a little bit more technical than my normal streams. But yeah, we'll get to stuff like Python dash plotly dash for Camus. I'll have this print 100 times. Let's do this. I love the chat times. I love the chat 0 to 100 times. Fun time print fun times. Okay. It's going to say fun, 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 fun. Every line, every print. Lots of fun. All right. Thanks everyone for hanging out tonight. I'm going to have to go to bed here soon. And it's been a fun time. So I'm going to get it working. I promise you. It's going to take a little bit of debugging of this code. And we're going to get this off the ground, and everyone's going to be so excited and impressed. Or I'm not going to do it and no one's really going to care. So thanks everyone for hanging out. Just a few things before I do leave. Exclamation point Discord will bring you to our Discord link, and that can be used to join the Discord, where we'll be talking about giving away this GPU back there. You can go to my YouTube. I think that's the right link. Let's make sure that's the right link. It is. And then you can also do my Twitch. And I'll also put in chat my Twitter. Those are all the ways to get in contact with me. Thanks for hanging out. We learned a little bit about how to use Pytorch Lightning, kinda. We didn't get super far with it, but we're trying to train a model using it. And this is the sort of stuff you have to go through when you're doing that, especially when you swap out back-end models from a code base that was using a different model. I'll see you all next time. Pretty soon, we're launching a Kaggle competition where you could win a free GPU. So make sure you stay tuned, tell your friends, and I'll see you all soon. Have a good one. Bye-bye.